world, because we're not given the height. Somebody other than in the classroom, because we've already discussed, somebody on Zoom, how could we find the height? Yeah, go for it.
Okay.
No.
You can just split the triangle in half up and down.
How am I allowed to do that?
Because you don't have a right triangle right now, so by splitting it in half, that like perpendicular to the base, you can make two right triangles.
Okay, that is so important. Yes, so we don't necessarily want to split it in half. We want to drop a line down so that it's perpendicular to the base. Braden, do you remember what that's called? It's okay. No, that's okay. No, we didn't in here either. Does anybody remember what the name of that is called? When you drop a line from the vertex to the base and it creates two right angles. Nobody? Oh, good guess. Perpendicular bisector, no, because we're not bisecting the opposite side, but that was a good guess. Starts with an A. Not attitude, but anybody? Altitude! Good job, you guys. It is the altitude. So when you draw an altitude in a triangle, it goes from the vertex to the opposite side, creating a perpendicular line with two right triangles. Okay, Braden. So we've got two triangles now. What do I do?
Well, I started with we needed to find the actual length of the height.
Excellent. Okay.
You want me to keep going?
Oh yeah. Unless you want to like call it, you could popcorn somebody.
Sure. Popcorn somebody.
Okay. Sorry, guys.
Michelle.
Oh, Michelle.
I knew you were gonna pick me. Okay. So we did sine 33 degrees equals x over 8, and we got 4.36 as the height.
Okay, hang on one sec. Wait, pause. Slow down. Sorry, Michelle. So then we multiply both sides by 8, because ultimately, if you guys are not following along for anybody, they're trying to find a height, yeah? So they use the second triangle, and if I may, you don't want to use the first triangle. Because if you're going to use a sine, cosine, or tangent trig ratio, you have to have at least one side length. Triangle 1 only has an angle. That's not helpful. So they use triangle 2. I'll stop talking. Michelle, go ahead. So what is the height?
4.36.
Perfect. If you rounded to 4.4, you guys, that's fine. Okay, keep going.
To find the base of that triangle on like the right, we did cosine 33 degrees equals x over 8.
Okay.
And then we got 6.71.
Okay.
Right, and then to find the base of the triangle on the left, we did tangent 67 degrees equals 4.36 over x to get 15.8.
Nice. Okay, hang on one second. So you did the tangent of 67 degrees?
Oh, wait. No, that's not right. That's not right. That's the answer, 15.8.
No, you're good, you're good. We were going to get to that in a second.
I don't think I wrote the answer down.
Braden, help her out. Because you guys are in the same group, right?
Yeah.
Okay.
So
we got 0.54.
yeah.
That's about 0.54. And then since now you have the base and height, you can just find the area.
Okay, sorry. X is what?
0.54.
For this distance? For the second triangle or for the first triangle?
Yeah.
0.54?
Braden, is that what you got?
Yeah, tangent 67 divided by 4.36.
Oh, haha, this is good. Okay, so we don't want to divide by 4.36 because if we were to do that, now you've got the tangent of 67, right, divided by 4.36, which is fine, but you have 1 over x. And we need to solve for x, and we talked about this earlier, yeah? We want to solve for x, so my suggestion would be in this part, you guys, multiply both sides by x. So then we have x times the tangent of 67 equal to 4.36. and then we can isolate x. Does that make sense?
Yeah.
Yeah, okay. You guys are doing a great job of setting this up though. Okay, so then what would we get? I'm calling it x prime to differentiate between the two sections, you guys, because if we call them both x, that's assuming that they're the same length. So that's why I'm differentiating with the prime. Okay, so then what do we get?
1.85.
1.85. Those of you that are in the class, are we agreeing so far? Yeah, okay, awesome. All right, Michelle, keep going. Take us home.
Well, I have different numbers because we messed up that one. So
That's okay.
1.85 plus 6.71 equals 8.56 times the height, which is 4.36, divided by 2 is 18.66.
Nice. Okay, so what she did, and she was running through it, she was handling it, nice job, is we need to add the two pieces to find the entire base. We had to find them in sections, but once we add them together, we get the whole base. Everybody okay with that? Yeah? Zoomers, we good? Okay, thank you. So then, to find our area, well, shoot, just as she said, it's 1/2 times the base, which we found to be 6.21, times the height, which we found to be 4.36. Now, disclaimer, like Nadia mentioned earlier, if you rounded differently, your answer is going to be a smidgen off. That's okay. And by a smidgen, I mean a tenth, not a whole number. So our area should be approximately, did we get 13.5 units squared? What did I do wrong? No? Anybody? Anybody?
Why is your base 6.21?
Because I added together what you told me. Oh, no, I didn't.
Okay.
Comical. Thanks, Michelle. Sorry. What was your base? It should be 8.56. Yeah. Thank you, hon. Sorry about that. Okay. And then 4. Okay, so then what did you get for the total, Michelle?
18.66.
Okay, what do we think, guys? Does that sound better? Yes. Okay, that was a lot, right? Holy heck. So we had to use trig to find the height, which is awesome. That's what we're doing right now. And then we had to piece together the missing parts of the triangle to get us the base. That's a lot of work to find the area in a non-right triangle, but it's possible, right? Okay, well, I have a question for you because I'm seeing something, but I want to make sure that I'm seeing it correctly. We have the area equal to half the base times the height, correct? Okay. Now, to find the height, we use the sine of 33 equal to the height over the hypotenuse, right? Technically, the height was equivalent to that. Do you agree? Yes, no? Yeah. And so the height was interesting. The height was a given side and the sine of a non-corresponding angle. In this case, it was little a and big B. So could I say, for this particular triangle that was given to us, that the area is equal to 1/2 times the base times a side and then the sine of the given angle? Could I say that? Yeah, for sure, right? Because it's equivalent to the given triangle. But let me ask you this. In the given triangle, what was the letter of our base? What's the letter of our base? Yeah, it's just C. So for our specific triangle, the base is C, and then we found the height by using the product of the non-corresponding side and the sine of the given angle. Will this work every time? if I'm given a triangle without the height? Will this work every time? Yes, yes it will. Ladies and gentlemen, I would like to introduce to you, where is my note guide? Another way to find the area. Oh no, don't look at this. Oopsies. Another way to find the area of a triangle if you are not given the height. Magical. Another way to find the area if you are not given the height. I'm so sorry, I thought I had erased this. Don't look at it. Pretend you're not seeing it. Okay, so going to our note guide. Go ahead and draw a triangle with me just like we saw on that warm-up. We're going to label this A, I want to stay consistent, C, and B. Now, we were given, remember, little a is across from big A, little b is across from big B, and little c is across from big C. Oopsies. There we go. Now, we were originally given, in number 1, we were given little a and big B. And you guys said to me, hey, let's drop down, well, technically it was Braden, Dean, and Colin. Let's drop down the altitude to create a height. And let's find it. Well, the law of sines gives us additional area formulas so that we don't have to go through that entire process. If we have little a and little b, or sorry, big B, we can find the area by saying 1/2. The base in this particular, because we're going to use this angle, in this particular situation is little c, and then we'll multiply it by little a times the sine of big B, just like we saw in the warm-up, because that represents the height. Okay, so to rearrange it just a little bit, I'm going to say 1/2 AC times the sine of big B, just to write it in alphabetical order. Now let's say, okay, we weren't given angle B. Hey, no problem. What if we're given little b and angle A? Well, okay. I can still use 1/2. My base with this setup is still little c. But now, in order to find the height, think about what we did earlier, yeah? We would have the sine of angle A equal to the height over little b, which means the height would be the product of b sine A. So this could then be substituted in just like we did for the previous triangle. Based off of the given information, we could find the area using 1/2 b times c times the sine of angle A. But it must be noted, this can only be used if you're given the information in the order of side, angle, side. This area formula can only be used if you're given side, angle, side. And we refer to that as the included angle. Okay, so we have a side, and then an included angle, and then the other side. In other words, it's sandwiched in between the two sides. Okay, it's included within that. But there is one more scenario. We could have 1/2 AB times the sine of angle C. It all depends on the information that we're given, you guys. So how do we use it? Ha-ha! Enter in example 5. Okay, so it's asking us to find the area I'm first off going to draw a triangle because I want to see what I'm given and how I can best use it to find the area. It doesn't matter what you label A, B, and C. I'm just going to label A, B, and C. What matters is that the given information is accurate. So we are told that little b is 35, little c is 23, and angle A is 36 degrees. Okay, well right away, I see it's side, angle, side. That's perfect. So I know that we can use our new area formula. 1/2 in this case, our sides are little b and little c. So I'm going to have 1/2 little b times little c times the sine of the given angle, which is angle A. And let's go ahead and plug in what we know. We're going to take 1/2 times 35 times 23 times the sine of 36 degrees. Okay, let's use our calculators. Make sure that you are in degree mode because we're using the sine of 36 degrees, just like we talked earlier. We'll take 1/2 times 35 times 23 times the sine of 36 degrees. And when you're ready, please round to the tenths. Somebody tell me, what is the area of this particular triangle? Yeah, Colin?
236.6 squared.
Haha, very nice, sir. 236.6, and Colin added in the units squared. We are dealing with area. It's important that we have units squared. Nice. Okay, in the classroom, any questions on area? Okay, on Zoom, any questions on area? Josh, you gonna make it? You look like you're falling asleep. Hang in there, sir. All right, well, let's go back to our area formulas. We've got 3 options depending on what's given to us, right? Could be 1/2 AC sine angle B, 1/2 BC sine A, or 1/2 AB sine C. All given to us in SAS, right? Side, angle, side. Well, let's reduce a little bit. They all have a 1/2 in them, right? Yeah, so I'm going to divide every piece by 1/2. And I can do this because I'm doing it to all 3 of them. So therefore, it is equal across the board. Okay, so then the 1/2s are going to cancel. And we're left with AC sine B is equal to BC sine A is equal to AB sine C. I'm just cleaning it up a little bit, we'll say. Well, gosh. The first 2 also have a little c in them, and I'd like to reduce that, but I have to reduce everything if I'm going to reduce any of these. So let's go ahead and divide everything by little c. And the first 2 area formulas will reduce the c's. The third one, it'll stay in the denominator. That's okay. Man, I also see that 2 of them have little a. So let's divide by little a just to keep reducing. But we still have to reduce all 3. So that will cancel and that will cancel. Do you guys see any other letters that occur in more than one of the area formulas? Yeah, Colin? Yeah, little b, right? So let's reduce by little b also. And it's going to reduce, but it stays in the first one. So cleaning it up a little bit, we're left with the sine of angle B over little b, the corresponding side, equal to the sine of angle A over little a, equal to the sine of angle C over little c. Well, that's interesting. Guess what? This is your law of sines. Ladies and gentlemen, this is another resource for us to be able to find missing side lengths, and missing angle measures when we're given a specific triangle. And this is super helpful because trig ratios, sine, cosine, tangent, those can only be used for right triangles. This, the law of sines, these proportions, these ratios, can be used for a non-right triangle. Super, super helpful. Make sure that you acknowledge also, it doesn't have to be all three ratios set equal to each other. We're just going to use them in proportion state. So I'll only have one ratio equal to another ratio. Okay, you're not ever going to use it where all three are equal to each other. That tends to be a misconception with the law of sines. Let's use it. Let's go. Off we go. Example number 6. Okay, 6a. Well, first off, it says round to the nearest tenth, so that's what we're going to be focusing on. And we're given some information. I have angle A and its corresponding side. Okay, so that's the given. We really want to try to use the given as much as possible so that our answers are as exact as possible. Okay? So I've got big A and little a. I have big B, but I don't have its corresponding side of little b, so that should be the first thing that we find. Let's use our law of sines because it's not a right triangle. So I'm going to say that the sine of big A over little a is equal to the sine of big B over little b. And let's plug in what we know. We know that angle A is 40, so we have the sine of 40 degrees over little a, which is 20. And I'm going to set this equal to the sine of 60 degrees, because that's angle B, over little b, because that's what we're trying to find right now. Caitlin and Jamie, can you guys see that okay? Okay, thank you. All right, it's a proportion. How do we solve a proportion? What do? Cross multiply. Oh, yes, Josh?
I was going to say you cross multiply.
Oh, I stole it from you. I'm so sorry. Nice job. Yes, cross multiply. So we get B times the sine of 40 degrees is equal to 20 times the sine of 60 degrees. All right, last thing that we need to do is divide by the sine of 40. So B is going to be the product of 20 and sine 60 divided by the sine of 40 degrees. Now, I am going to show us on our calculator real quick. Be careful, you guys. There is room for error on this and how you put it into your calculator. Okay, so you can do it in sections, okay, and that would be my suggestion. Oh, I always forget. Okay, what's in the numerator again? And then divided by sine of 40? Okay, thank you so much. Because I can't see that on my screen, you guys, when I'm sharing the calculator, so my apologies. All right, so I'm going to do the numerator first and then divide. I'm going to do it in pieces. This is an option if you're not comfortable with the use of parentheses. So I'm going to simply say 20 times the sine of 60. Again, we already know our calculators are in degree mode because we've already set that to be such. And I'm going to hit enter. And your calculator has this incredible option for building off the previous answer without approximating. So I'm just going to click divide, and it will use this entire answer. It will not approximate for me by the sine of 40. So we get approximately 26.9. Now, if you want to do it in one fell swoop, totally fine. But you need to tell your calculator that you're entering in the numerator's quantity first. So parentheses 20 times the sine of 60 Now your calculator prompted you for a parenthesis with the sine measurement, so I close that. And I need to close the numerator quantity also. And then I'm going to divide by the sine of 40. And I get 26.9 again. Okay, so either option, just be careful with your parentheses because your calculator does follow the order of operations. Okay, so we're going to say dun, 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 that b, little b, is approximately 26.9 units. Okay, so we know what little b is. Oh, nice. So if I know that little b is 26.9 and I know that little a is 20, I can just use the Pythagorean theorem to find little c, right? No, because this is not a right triangle. But we're so ingrained in our heads right now with, oh, Pythagorean theorem, sine, cosine, tangent. Be careful. This is not a right triangle. You cannot use the Pythagorean theorem. What we can do is find angle C and then find little c. Now think about angles within a triangle. There are 3, and they always add up to what? 180. So we know for the measure of angle C that I can take 180 degrees and subtract the sum of the other 2. What is the measure of angle C? 80 degrees. Excellent. And now that allows us to find little c. Using the law of sines again, I'm going to go back to the pair of given information that was capital A and little a. So I'm going to say that the sine, oh golly, me and my colors, that the sine of big A, I don't know why it's lagging, you guys, sorry about that, over little a is equal to the sine of big C over little c. Okay, let's plug in what we know. So the sine of big A, which is 40 degrees, over little a, which is 20. And again, I'm going back to the given information because that wasn't approximated. Okay, so that way my answers will be a little bit more exact. Equal to the sine of 80 degrees, which is angle C, over little c. Cross multiplying, we get little c times the sine of 40 degrees, equal to 20 times the sine of 80. Grand finale, we get to divide. So little c is equal to 20 times the sine of 80 all over the sine of 40 degrees. All right, using our handy dandy calculators, what do we get for little c? Anybody? Nadia, are you typing? You look like you're typing.
Yeah, it was 30.6.
Yes, yes, thank you, my dear. 30.6, and we'll round to the tenths. Ladies and gentlemen, we have solved our first triangle with the law of sines. Any questions on example 6a? No? All right, let's do another one. Off we go. Off we go to example B. Okay, identifying, and I don't know if you've noticed, but I am using colors for the identified versus the new stuff. So we were given angle A, and we have the corresponding side, because it's right across from it, we know little a. Okay? We have little b. So really, the only option is for us to find angle b with the given information. Notice, the law of sines can be used on any triangle. You don't have to have the order of side, angle, side in this situation. The only time you need to have the information given to you in side, angle, side order is when you're going to use the area formula. Okay, big important distinction. So here we go. Let us find angle B. The sine of angle A over little a is going to be equal to the sine of big B over little b. I just realized what time it is, so I'm going to talk really fast, really sorry. Okay, so we have the sine of 42 degrees over 63 is equal to the sine of angle B over 57. Heads up, we're going to have to use the inverse because we're finding the angle measure. So the sine of angle B, I'm just going to multiply 57 to both sides. In this case, I don't actually need to go through the whole proportion process. It's going to be 57 times the sine of 42 degrees all over 63. And then we're going to have to take the inverse. So the inverse sine of that ratio is going to give us angle B. Please do this in sections if you need to. You could do 57 times the sine of 42 and press enter, divide it by 63 and press enter, and then you can take the inverse sine of your answer, and we should get that the measure of angle B is approximately 37.3 degrees. Now, using the idea that three angles within a triangle add up to 180, I'm going to take 180 degrees and subtract the sum of angle A and angle B, and that's going to give us that the measure of angle C is approximately 100.7 degrees. All right, ladies and gentlemen, grand finale. Can I make it in the time allotted? Probably not. So I'm going to say that the sine of angle A over little a is equal to the sine, we have to find little c, I knew it, of capital C over little c. Okay, so go ahead and finish this one example on your own. Example C, you guys, I am not going to look for in your note guide. We will cover this together in class next week. Do not do example C, please, on your own, okay? I will post the answer for this one, or I'll just email it to you guys so you can correct your answers, okay? Have a fantastic weekend, you guys. Bye. I'm going to finish it real quick in case you want to see it. Over 63. And for those of you that are not in class today, and I'm recording it for you, here you go. Bye, thank you. Bye, you guys. Okay, so then putting it into our calculator, sine of 100.7, close, divided by the sine of 42, we should get that little c is approximately 92.5. Boom! If I put it into my calculator right, we are solid. Ay, ay.